I am Bernard Martin, faculty in the Department of Industrial and Operations Engineering, and more specifically a faculty in the Center for Ergonomics. My interest lies in human-machine interactions, and today I'm going to talk very briefly about some studies that we do that are associated with touchscreens. This technology is currently invading our everyday life, and we have more and more devices that are equipped with touchscreens, such as iPhone, iPad, and other devices. But the introduction of touchscreen is also going into the industrial world, and there are many applications in which people want to interact actively with the screen rather than using controls and buttons. So the one that I'm concentrated on here is an interface that is used to manipulate text, pictures, images on a computer screen, and whether the use of this touchscreen may lead to muscle fatigue and if repetitively used day in, day out for application, whether that could contribute to long-term musculoskeletal disorder. So the specific experiment that we have focused on consisted in simply having a task simulated on the computer screen equipped with a touch screen, and we require the subject to manipulate objects such as moving them around with one finger or expanding or contracting the size of the object presented on the screen with a specific requirement of position or size. To capture the movement of the finger, the wrist, and the upper limb, and also the head and torso, we need to place markers on this body segment. These markers are light-emitting diodes that are emitting a light in the infrared range, so they are not visible to the naked eye, but they can be captured by specific cameras. The idea was to record objective measure of what the movements are when performing this task, and then trying to associate this movement and duration of movement or precision requirement with any discomfort or perception of fatigue. In that particular experiment, the results show that effectively the elevation of the screen and the inclination of the screen had an influence on the angle of the wrist, but also had some effect on the visibility of the screen, as some glare from the overhead light could interfere with the visual perception of the images. We also determined that the precision of the task is something that is very difficult to achieve on a touch screen, and so that's one of the issues that we are looking into now in order to determine what is the level of precision that can be achieved with a touch screen, and is it compatible with tasks that are simple computer tasks, or whether they are compatible with other tasks that may be more of industrial application for this touchscreen. So that's why we always try to investigate more deeply into the mechanism associated with muscle fatigue, as well as the reason why somebody would feel more or less comfortable when using a specific device or adopting a certain posture to perform a certain task.